Hello students, welcome to my YouTube channel Integrated Physics Studies IPS. एथरे मु ऑलरेडी प्लस 2 सेकंड ईयर सिलेबस कंप्लीट कर सारछि एबे मु प्लस 3 सीबीसीएस ऑनलाइन क्लासेस रो वीडियोज गुडा अपलोड करिवि जदि भल लागिला ताले लाइक कर देबो एवं सब्सक्राइब कर देबो जो वीडियोज गुडा मु अपलोड करिवि तार नोटिफिकेशन पई एठी बेल आइकन को ऑल रे सेट कर देबो गोटे इंपोर्टेंट जिंस वीडियोज रो ऊपर एठी जो 3 डॉट्स देखुछो तार क्वालिटी एठी देखो बाय डिफॉल्ट 360 अछि तमे ताकू पढे मध्ये परिबो एठी एडवांस रे क्लिक करी तमे रिजोल्यूशन बढ़े परिबो प्रति वीडियोज रे मु पीडीएफ लिंक देबी ताकू एठी ड्रॉप डाउन लिस्ट रो तमे क्लिक करी डाउनलोड मध्ये करि परिबो पीडीएफ को लास्ट रे एठी जो मोर चैनल नेम अछि याकू क्लिक करी तमे एठी प्ले लिस्ट को जाई मु प्रति वीडियोज को यूनिट वाइज एज पर सिलेबस सजाई की रखिथिबी तमे सर्च करि परिबो ओके थैंक यू हेलो स्टूडेंट्स आज रो टॉपिक रे हमें मैग्नेटिक क्वांटम वेल मैग्नेटिक डॉट्स और मैग्नेटिक डाटा स्टोरेज विषय रे पढिबा. So first of all, what is a magnetic quantum well? It is actually a potential well with only discrete energy values. And this magnetic quantum well is formed in magnetic semiconductors which are sandwiched between two layers of a material with a wider band gap. Okay. The magnetic semiconductors are the semiconductors which exhibit the property of ferromagnetism. Okay, and these semiconductors would allow control of quantum spin state if implemented in the devices. Okay, and the dilute magnetic semiconductors, that is in short DMS, are semiconductors which are doped with transition metals, and these magnetic semiconductors are used in spintronics, okay, which you have already read in nuclear physics. So spintronics means it is the study of intrinsic spin of electron and its magnetic moment in addition to the electronic charge in the solid state devices. Okay, now the magnetic quantum well can be grown by molecular beam epitaxy or chemical vapor deposition, that is CVD, with control of layer of thickness down the monolayers. Now thin metal films can also support the quantum wells states. In particular, the metallic thin layer are grown in the metal and magnetic semiconductor surfaces. The electron or hole, which is confined by the vacuum metal interface in one side and by an absolute gap with the semiconductor substances, or by projected band gap with the metal substrate. Okay, now magnetic quantum wells are used for the fabrication of spin transistors and spin polarized LEDs, that is the light emitting diodes. Now secondly, magnetic quantum dots, which are actually very small magnetic semiconductor particles having several nanometers in their size. Okay, and they are so small that their optical and electronic properties differ from those of larger particles, which we are studying from the beginning of nanomaterials, that whenever we are going from larger particle to nano dimension, then its property changes. Okay, so they emit light of specific frequency if electricity or light is being applied to them, and they tightly confine the electrons or holes. Okay, magnetic quantum dot is a single object with bound or discrete states, as in case of your atoms. Hence the magnetic quantum dots referred to as artificial atoms. Okay, now they show the properties which are intermediate between those of your bulk semiconductors and those of discrete molecules, and their optoelectronic properties change with the change of shape and size. Okay, now larger magnetic quantum dots, which are having size of 5 to 6 nanometer, they emit light of longer wavelengths, and it will result in emission of colors such as orange or red. Okay, remember orange or red is a color having larger wavelength in the visible spectrum. Okay, now smaller magnetic quantum dots having size that of your 2 to 3 nanometer will emit light of shorter wavelengths, resulting in emission of colors such as blue and green. Okay, the magnetic quantum dots are used in case of your transistors, then solar cells, LEDs, diode lasers, then quantum computing, medical imaging, then inkjet printing and spin coating. Okay, now come to the third one, which is the magnetic data storage. So you can see from its name, it will store the data on a magnetized material. Okay, so magnetic storage is also known as magnetic recording. Okay, it uses different patterns of magnetization in a magnetic material in order to store the data, and it is a form of non-volatile memory. Now the information is accessed by using one or more read or write heads. Okay, so hard disk in this case are magnetic storage devices which are widely used to store the computer data as well as audio and video signals. Okay, now the term magnetic storage is preferred in the field of the computing, and the term magnetic recording is preferred in the field of audio and video production. Okay, other magnetic storage devices are like your floppy disks, then magnetic tape, magnetic strips on debit and credit cards. Okay, which you have seen, like that of your ATM card, there is a magnetic strip which is black in color, you might have noticed. Okay, now early magnetic storage devices were used to record the analog audio signals, and now the computers and most audio and video magnetic storage devices record the digital data. Okay, now in old computer systems, the magnetic storage was used to primarily store in a form of magnetic drum or core memory, and thin film memory, twister memory, then bubble memory, etc. So these are all the types of storage, okay, in the old computer system. But now in the modern computer system, the magnetic tape is also used for the secondary storage purpose. Now the information is written to and read from the storage medium as it moves past the read and write heads that operate very close over the magnetic surface. And here the read and write head is used to detect and modify the magnetization of the material under it. Okay, and there are two types of magnetic polarities, each of which is used to represent either 0 or 1, as in case of your binary number system. Okay, now in case of the older hard disk drive, the magnetic regions were oriented horizontally and parallel to the disk surface, but in the modern hard disk drive, the magnetic regions were oriented vertically and perpendicular to the disk surface. So this is the basic difference. Again, the whole older hard disk drives uses the ferrous oxide as the magnetic material, but the modern disk uses cobalt based alloys as the magnetic material. Okay, magnetic nanostructures are being developed for the data storage purpose with high capacity because they have unique mechanical, electronic and magnetic properties, as we know, and this will cause strong confinement of electrons, photons and phonons at the nanoscale. Okay, now let us classify the magnetic data storage system. First we have the magnetic memory, how the memory is being stored in a magnetic material. Okay, so magnetic memory includes recording of digital information on magnetic tape or hard disk or your floppy disk. Okay, so three types basically. Now the magnetic storage devices are quite sophisticated and are being externally assessed. Okay, now these magnetic memories are capable of storing large quantities of digital data, and magnetic disks such as your hard disk and floppy disk are referred to as mass memory because they can store huge amounts of data. Okay, and these magnetic disks are important components in almost all the micro and mini computers. Okay, large reels of magnetic tape are economical and widely used in the mass storage components in the large computer system. Okay, now the basic principle which is used in each case is the magnetization of small spots in the thin film of the magnetic material. Okay, so this is the basic principle, and the principle of writing, that means recording or storing the data in form of binary system on a magnetic surface, is shown in the figure. So you can see this is the figure, and here the right head is a small electromagnet. Okay, this one, it is a small electromagnet which is placed very close to the moving magnetic surface. Okay, so you can see when an input pulse of voltage is being applied to the coil of the electromagnet, then the region of the magnetic surface which is under the electromagnet, this will be magnetized in a certain direction. Okay, this you have read in magnetic effects of current and electromagnetic induction. Now similarly, when the voltage pulse of opposite polarity will be applied, then the region under the electromagnet will be again magnetized, but now in the opposite direction. Okay, so a data bit of 1 or 0 is thus imprinted on the region, disregarding the existing state of magnetization of the region. Okay, and here the principle of reading the binary data from the magnetic surface is again shown in the figure, which is quite similar to that of the magnetic recording. Okay, so here again you can see this is a very small electromagnet which is placed very close to the moving magnetic surface. Okay, now the magnetized region, that is the recording 1 or 0 under the electromagnet, will induce a voltage pulse of certain polarity in the coil depending upon the direction of magnetization of the region, and it will indicate whether the recorded bit is either 1 or 0. Okay, and in most the cases the reading head and the writing head are combined to form a single unit which is known as dual read write head. Okay, so moving on, the next one is the magnetic tap. Okay, so magnetic tap, here the storage is actually non-volatile and it has immense capacity of storing the data at relatively low cost per bit, and it is a mass storage device and it has also backup. Okay, so a single magnetic tap may be of very long length and can store thousands of megabyte. Okay, so it is a very large quantity of storing the data. Okay, and here the magnetic tab is wound on the reels and must be unwound to read and write. Okay, but here the main drawback or disadvantage of this magnetic tab is the long time required to access a specific block of data. Okay, and the magnetic tab is produced by deposition of a thin film of magnetic material on a long strip of plastic, which is then wound on a reel. Okay, now the adjacent regions on the surface of the magnetic tap are magnetized with one polarity on the other in order to represent the binary 1 and 0, and the dual read write head is then used to sense or alter the magnetization. Okay, and here the data can be recorded on the magnetic tape either in coded form or in binary form, that is 1 or 0. Now either 7 or 9 dual read write heads are connected in parallel for the use with magnetic tape, and as the magnetic tab moves past the heads, the data is being read or written. Okay, now in the 7-bit system, here the alpha numeric information is recorded in the coded form and there is one parity bit. Similarly, in the 9-bit system, the data is composed of 8 bits and the ninth bit is that of for the parity, either even or odd. Okay, so the data storage on a magnetic tape is sequential. Okay, next one is the hard disk. So hard disk is produced by deposition of magnetic material on a thin circular rigid disk, which is usually that of aluminum. Okay, and it is a secondary storage device which is used for both sequential and random access. Okay, the recorded data can be read many times without disturbing the recorded information, and the recorded data can be erased and new data can also be recorded. So this is a benefit in case of your hard disk. Hence the hard disk are known as read write devices. Okay, and they can store several gigabytes of data. Okay, now the hard disk is sealed along with its drive mechanism in a dust free environment, so it is quite sophisticated, right? In a hard disk, small magnetized patches are created on a magnetic coating in order to record the data. Okay, and the magnetization in a certain direction of a patch will represent a binary 0, but the magnetization in the opposite direction of a patch will represent similarly a binary 1. Okay, the binary bits are recorded on concentric circles which are called tracks, and these tracks are further divided into sectors as shown in the figure. So you can see in this figure, this is that of your hard disk. Okay, here the concentric circle which are shown by these dotted lines are actually the tracks. Okay, and the sectors, that this one, okay, this is a sector. Okay, this small part, right, between two concentric circle in one region. Okay, similarly this is another sector, right. Okay, so the hard disk used in small computer systems are having diameter up to 3.5 to 5.25 inches. The hard disk drive with 40 to 400 gigabyte capacities are most common in the microcomputer systems. The hard disk is rotated at a speed of about 3600 to 7200 rpm, that is rotation per minute, and in high end computer the hard disk rotates at a speed of 1500 rpm, resulting in ss time of 16 to 36 milliseconds. Okay, hard disks are widely used in computer system because of short ss time and high storage capacity. The number of tracks and sectors are actually different for different computer systems and also for different manufacturers of the computer. Okay, the smaller hard disk which is used in microcomputer system are having around 300 tracks. In a modern computer system, there are options to use 3.5-inch hard drives with capacity of 80 GB and above, then 2.5-inch hard drive with capacity 40 to 120 GB, then palm size pocket hard drive of capacity 2.5 GB and 5 GB in addition to the internal hard disk. Okay, the next one is the floppy disk. So floppy disk is produced by the deposition of magnetic material on a semi-rigid plastic disk. Okay, floppy disks are also known as diskettes or floppies, and these floppy disks are permanently housed in a flexible square jacket that protects the disk from dust. So again, it is a sophisticated device. Okay, so this is the diagram of a floppy disk. As you can see, this one is the read write ss, this is the spindle drive hole, then the index ss hole, and this is the write protected notch. Okay, so the read write ss or opening will provide an ss for the read and write head, then the index ss hole will allow the use of photosensor to establish a reference position. Okay, now when this write protect notch is covered, then the data cannot be recorded on the disk and the loss of data is being prevented. Okay, so the floppy disk is actually a portable storage device, and it must be inserted into a disk drive. Okay, the disk drive unit consists of a single read write head and a write mechanism and a track positioning mechanism. Okay, now the spindle drive rotates the magnetic disk at a speed of 360 rotation per minute. Hence, the SS time for the floppy disk is about 80 milliseconds, and it is a random SS device. Okay, and also it is divided into tracks and sectors as in case of your hard disk, depending upon the data which is to be recorded. Okay, now double-sided high density 5.25-inch floppy disk will have a capacity of 1.2 MB. Then double-sided high-density 3.5-inch floppy disk will have a capacity of 2.88 MB. Okay, let us have some of the problems which are given in the example. Here in example 1, a single sided double density 8-inch floppy disk has tracks which are numbered 0 to 76 and sectors which are numbered 0 to 25. Then it was asking that what is the total storage capacity of the disk. Okay, so you can see 0 to 76 is the total number of tracks, that means it will be 77. Similarly 0 to 25 is the total number of sectors, so it is 26. Okay, now let us say that the bytes per sector, okay, number of bytes per sector is 256. Then the storage capacity of the disk will be the product of number of tracks, then number of sectors and bytes per sector. Okay, so 77 into 26 into 256, so this will be 5,12,512 bytes. Okay, similarly example 2, the total storage capacity of a floppy disk having 80 number of tracks and storing 128 bytes per sector is 163840 bytes. Then what will be the number of sectors of the disk? So applying the same formula, the number of sectors is found out to be equal to 16. Okay, so up to this I have taken the magnetic quantum well, magnetic dots and magnetic data storage from one book. Now this is taken from another book where the magnetic storage is only given. Okay, so you can also read it for your knowledge purpose. Okay, so it has given emphasis on the read and write heads. Then we have the types of magnetic recording. Okay, analog recording, then your digital recording, then magneto optical recording, then domain propagation memory. Okay, then your SS methods, which is of two types, that is sequential and random SS. Then use of magnetic storage, like it can be used as the mass storage of data in the hard disk of computers. Then recording of analog audio and video works on computer tab. Then magnetic ink character recognition code, that is MICR checks of your bank. Okay, so MICR number is there, which is in the bank checks. Okay, you might have noticed. So these are your magnetic ink character recognition. Then the last one is the magnetic strips on the credit and debit cards, that is your ATM cards, right? Now the types of magnetic storage devices. Okay, this is broadly classified into like that of your fixed storage devices, then removable storage devices, which is your portable hard drive. Okay, having advantages like that these are cheap, then reliable, they offer high speed accessibility. Then your magnetic tab, which we have already read. Okay, they have advantages and also disadvantages like durability. So if any area of the tab is damaged or broken, then entire roll can become useless and hence the tab might not be very durable. The second problem is small amount of available space for the data storage. So due to such disadvantages, the magnetic tab is now almost obsolete. Okay, the second one is the floppy disk, which we have already read. Then it has given about the zip disk, which is actually a portable storage medium like that of your floppy disk with higher storage capacity, which is around 100, 250, 750 MB, and it uses random access. Okay, but still these devices again have become obsolete due to the emergence of CD-ROMs and CDRs. Okay, along with these, it has given a comparison between the traditional and new magnetic storage technologies, so you can read it for your knowledge purpose. Now let us go further. It has given about the GMR, that is the giant magneto resistance, which is a quantum mechanical magneto-resistance effect, and it is observed in multi-layers composed of alternating ferromagnetic and non-magnetic conductive layers. Okay, this effect is concerned with the occurrence of significant change in the electrical resistance depending on whether the magnetization of adjacent ferromagnetic layers are in a parallel or anti-parallel alignment. Okay, so a low resistance is observed for parallel alignment, whereas high resistance for anti-parallel alignment. And this effect is based on the dependence of electron scattering responsible for the resistance on the orientation of spins. So for this discovery, that is GMR, two scientists, Albert Fert and Peter Gruenberg, were awarded the Nobel Prize in Physics in the year 2007. Okay, then it has given the applications of GMR. Okay, like GMR is utilized in magnetic field sensors, which are used in HDD and biosensors, and MEMS. Okay, so here HDDs are nothing but the hard disk drives, and MEMS, as you know, these are the micro electromechanical systems. Now the second application is GMR multi-layer structures, which are also used in MRAM as cells that store 1 bit of information. Okay, then finally the MRAM, that is magnetic random access memory, which is the future magnetic storage device of computers, and it stores the data in magnetic bits, which is based on the tunnel magnetoresistance, that is TMR effect. Okay, so you can also read it for your knowledge purpose. And this MRAM is useful in applications where moderate amount of storage with a need with very frequent updates are required. Okay, then it has given about the advantages and disadvantages of this MRAM. Okay, the advantages are like it is a non-volatile storage, then low power consumption is required, then high speed operation, then good shock robustness. So robustness means strong or ability to withstand. Okay, however the disadvantage is low storage capacity, which is smaller than that of the HDDs, that is the hard disk drives. Okay, so this is all about the magnetic quantum well, magnetic dots and magnetic data storage. Now again I advise you to go through both the books that I have given in the PDF, and you prepare your note accordingly by combining from both of them. Okay, thank you.